In this problem, we're going to be dividing radical expressions and simplifying, leaving the denominator free of radicals. This is also called rationalizing the denominator. So I want to recognize when I have something like 1 over the square root of 5 that I cannot leave a radical in the denominator and have that fraction be in simplified form. So I'm going to rewrite my original problem here, 1 over square root of 5, and I'm going to multiply numerator and denominator by a radical that will eliminate the radical in the denominator. And that is to multiply the square root of 5 times itself. So I multiply square root of 5 over square root of 5, and then I multiply across. So 1 times the square root of 5 is square root of 5. I'm multiplying this way. Square root of 5 times the square root of 5 is the square root of 25. I can simplify one more step, the square root of 5 divided by square root of 25, which is 5. So 1 over the square root of 5 is equivalent to square root of 5 over 5. The square root of 5 over 5 does not have radicals in the denominator. For part B, 3 over the square root of 20, it can be helpful in problems like this. The square root of 20 can be simplified just a little bit. So let's do that first, and then it makes our multiplication a little bit easier. Square root of 20 is the square root of 4 times the square root of 5. That becomes 3 over 2 times the square root of 5, because the square root of 4 is 2. Now, all I have to do is multiply numerator and denominator by the square root of 5. So this is the only part I need to worry about here. I multiply straight across. 3 times the square root of 5 is just 3 times the square root of 5. I have 2 times, now square root of 5 times square root of 5. This is square root of 25. Also reduces, and that will reduce to 5. So 3 times the square root of 5 over 10. So here was our original form with the radical in the denominator. 3 times the square root of 5 is an equivalent form with no radical in the denominator.